Hi friends, welcome to Varun Techie channel, a place for better learning. Today we'll learn Machine Learning Session 17. We'll see about Support Vector Machine Algorithm. Support vector machine or SVM is one of the most popular supervised learning algorithms which is used for classification as well as regression problems. However, primarily it is used for classification problems in machine learning. The goal of SVM algorithm is to create the best line or best boundary that can segregate n-dimensional space into classes so that we can easily put the new data point in the correct category in the future. This best decision boundary is called a hyperplane. Support vector machine chooses the extreme points or vectors that help in creating the hyperplane. These extreme cases are called as support vectors, and hence algorithm is termed as support vector machine algorithm. Consider the diagram in which here we can see the negative hyperplane, we can see the positive hyperplane, maximum margin hyperplane, and the support vectors we can see which are nearer to that hyperplane are called the support vectors. SVM can be understood with the help of that we have used in the KNN classifier. Suppose we see a strange cat that also has some features of dogs. So if we want to model that can accurately identify whether it is a cat or a dog. So, such a model can be created by using the support vector machine algorithm. We will first train our model with lots of images of cats and dogs so that it can learn about different features of cats and dogs, and then we test it with the strange creature. So, as the support vector creates a decision boundary between the two data, that is cat and dog, and choose extreme cases, it will see the extreme case of cat and dog. On the basis of the support vectors, it will classify it as a cat. See the diagram, here we have cat, dog, both data, and we are training the model. After that we are predicting with the new data and we are getting the output. Hyperplane. What is a hyperplane? There can be multiple lines or decision boundaries to segregate the classes in n-dimensional space, but we need to find out the best decision boundary that helps to classify the data points. This best boundary is known as the hyperplane of the support vector machine. The dimensions of the hyperplane depend on the features present in the dataset, which means if there are two features, then hyperplane will be a straight line, and if there are three features, then hyperplane will be a two-dimensional plane. We always create a hyperplane that has a maximum margin, which means the maximum distance between the data points. What are the support vectors? The data points are vectors that are closest to the hyperplane and which affect the position of the hyperplane are termed as support vector. Since these vectors support the hyperplane, hence called a support vector. Now we will see the code. I will explain the code in the Google Collaborator. First you import the necessary libraries, pandas as PD. After that from sklearn.model underscore selection, import train underscore test underscore split. From sklearn.preprocessing, import standard scalar. From sklearn.svm, import svc. From sklearn.metrics, import accuracy underscore score. After that, you load the data set from the Excel file. For that, you need to give the file path. You replace this path with the actual path of your Excel file. After that, we should write data frame df equal to pd dot read underscore excel of file underscore path. After that, we should assume the target variable in the column as target. Df x equal to df dot drop of target comma axis equal to 1, except the target remaining are in the x-axis, target is in the y-axis. Now we are taking x underscore train comma x underscore test comma y underscore train comma y underscore test equal to train underscore test underscore split of x comma y comma test size equal to 0.2 comma random state equal to 42. Means we are splitting the data set into training and testing sets. After that we are standardizing the features. Scalar equal to standard scalar of x underscore train equal to scalar dot fit underscore transform of x underscore train x underscore test equal to scalar dot transform of x underscore test. SVM model equal to SVC of kernel equal to linear SVM we are taking, and C equal to 1.0 means we are creating a support vector machine model. After that we are training the SVM model using SVM underscore model dot fit of x underscore train comma y underscore train. After that we are making predictions on the test data, means y pred equal to SVM underscore model dot predict of x underscore test. After that we are evaluating the accuracy of the model by writing accuracy equal to accuracy underscore score of y underscore test comma y underscore pred. Print of f accuracy, we are going to print the accuracy of the model. After that, thank you so much friends. Like, share and subscribe for more interesting videos.